Here are some examples of solving multi-step equations. Problem 1. Solve the equation 3p minus 2 equals 7. Let's start by writing the equation 3p minus 2 equals 7. Now we want to get just 3p on the left side, so let's add 2 to both sides. 3p minus 2 plus 2 equals 7 plus 2. The minus 2 and plus 2 cancel, so now we just have 3p equals 9. Now to find p, we want to divide both sides by 3. So 3p over 3 equals 9 over 3. The 3's on the left side cancel, and we have p equals 3. Problem 2. Solve the equation 5 plus c all over 6 is equal to 2. Again, let's start by writing the equation 5 plus c over 6 equals 2. Now we want to undo this division by 6, so let's multiply both sides by 6. 6 times 5 plus c over 6 equals 6 times 2. Now these 6's will cancel, and we have 5 plus c equals 12. Now let's subtract 5 from both sides. 5 plus c minus 5 equals 12 minus 5. The plus 5 and the minus 5 cancel, and we have c equals 7. Problem 3. 12 decreased by twice a number is minus 30. What is this number? So let's call this number n. Then the problem says that if we start with 12 and we subtract twice n, so 2 times n, then this will be equal to minus 30. Now we have an equation that we can solve for n. First, let's subtract 12 from both sides of the equation. So 12 minus 2n minus 12 equals minus 30 minus 12. The 12 cancels with the minus 12, so now we just have minus 2n on the left side, and this is equal to minus 42. Now let's divide both sides by minus 2. So minus 2n over minus 2 equals minus 42 over minus 2. The minus 2 on top cancels with the minus 2 on the bottom of the left side, and we're just left with n is equal to 21. Let's check our work. If we plug 21 in for n in our original equation, we have 12 minus 2 times 21 equals minus 30. If we calculate the left side, then we have 12 minus 42, and if we subtract these, we get minus 30, which is the same as the right side. So 21 is the right answer. Problem 4. Find 3 consecutive integers that sum to 27. Let's call the lowest of these integers n. Then the 3 integers have to be n, n plus 1, and n plus 2, since they are consecutive. Now we know that their sum has to be 27, so n plus 1 plus n plus 2 equals 27. If we simplify the left side and group together the n's, this is 3n plus 3 equals 27. Now that we have a nice equation, let's subtract 3 from both sides to try to solve this. 3n plus 3 minus 3 equals 27 minus 3. So now we can cancel out these 3's and have 3n equals 24. Now we can divide both sides by 3, so that 3n over 3 equals 24 over 3, and the 3's cancel again, so n is equal to 8. Now up here, we said that our 3 consecutive integers were n, n plus 1, and n plus 2. Since n is equal to 8, we must have 8, 9, and 10. Now let's check to see it actually solves the problem. 8 plus 9 plus 10 equals 17 plus 10, which is equal to 27. So their sum is 27.